Hello everyone, and welcome back to a new episode of SHENZHEN I. We just wrapped up building that audio thingy, and
The rubbish audio thing. And we have a message here about a self-driving car stuck in a loop. You may be entitled to a settlement. Oh yes, I see. So all of our a rogue loop. Oh, okay, this could be cute. If you bought a self-driving car in the past 5 years and it was involved in a rogue loop incident, you may be entitled to compensation under a settlement in a class action lawsuit filed in the U.S. District Court for the Southern District of California. I don't think that's a real thing. A rogue loop is defined by the court as a state where a self-driving car appears to disregard humans and continues to drive around, refueling itself when necessary and ignoring orders to stop. You believe it's experienced this in the last 5 years. Talk to us about how to submit a claim. All right. But instead, bring out the Baron. The Baron von Schnaps is in the house. I was out drinking and met someone from the company that owns this brand. There's a drinking game they're promoting that's hella fun and off the rails. I made a deal to supply them with little personal scorekeepers they can give away. It doesn't matter what the rules are, we are building a scorekeeper.
okay, begin.
Whoa, what is this? Okay, point and foul are simple inputs connected to buttons.
Can I zoom or anything? Apparently not.
Display is an XBus output connected to a numerical display. The counter should keep track of a count starting at 0 and constantly update. Okay, so when the thing
What am I saying? This is the first time that we have a button where we care about its rising or falling edge rather than about its state at a given time. Rather than its instantaneous state, we care about the change, the transition in its state. So yeah, okay, so a point input means add 1, and a foul input means subtract 1. Fine. So every step... Ooh, do we have one where both buttons are pressed at the same time? I don't see any madman doing that, but you never know. I can't find a way to scroll this. Oh right, it was this. That was how. It does not seem that we have that. Okay. Unclear whether we can count on that or not. But for now, that's how it seems to be. So what does that mean? We have a data register. Like, is that useful to us? Huh. Right, this thing has like an extra register that we haven't been using at all. State. Oh no, state was like exact. That's not a thing we have access to. This guy has a DAT register we can use. Alright. So what... Can we build a single chip of this size that detects rising edges in 2 different buttons? That sounds like quite an endeavor. It could be possible, though. So there are sort of 4 different states that this thing could be in, corresponding to what the inputs were on the previous iteration, right? It can either be in the state that none of them were on, or in the state that the first was on, or in the state that the second was on, or in the state that all 4 of them were on. And in each of those cases, it should have a different reaction to the different ways that the buttons could be active. But since the only way that we have to store state is in basically the program counter, i.e. which line of code we're executing, there's only 9 lines, like, we would have to be able to handle each state in only 2 lines, and like, I just don't think that we can do that. So, what I propose to do instead is use 1 chip for each of these guys, tracking the rising edge, and have them each communicate over XBus to a 3rd chip, a delta in score, and then that 3rd chip will communicate with display. And each of these can be quite simple, so we should not need any more than these little guys here. There's sort of this awkward problem, I guess, that I'm thinking about the fact that this guy only has 2 XBus ports, right? What happens if you share an XBus port and 2 guys write to it and 1 guy reads from it? Does it just work?
Let's find out. So let's say I do that. And that. And this guy just says move from X0 to ACK. And that's all he does. Meanwhile, these guys say move 10 to X0, or X1, I guess. And this guy says move 5 to X1. What happens? This guy happens to send his 5. Okay, and that guy gets to... Interesting. Only one of them ever sends anything. Why? Alright, let's say I told this guy then to sleep for a bit. He sends a thing, that guy sends a thing. And now that guy sends things forever. Okay.
So, as long as we sleep, we can get all the signals, right? Yeah. So what we're gonna do, I guess, is have this guy use... Wait. Does XBus carry any, like, state? Does it know what the previous value was? So let's start again. It's in write state, and there's a 5 here, but it's not exactly on the port. Yeah, it's gone. Not like the way it is for Simple I/O. Simple I/O, it sort of stays on the wire forever. How exactly do we, like, keep track of an old state then? Just leave it in ACK forever, I guess, right? But then it's hard to even add to it, right? No, it's not. Yeah, okay. So here's this guy's control loop, right? He, his ACK starts at 0, and we're connecting this up to there. And his control loop is just sleep on X0, add X0, move ACK to X1. right? So let's see what this does in practice. We send a 5 over. This guy reads from x0, bloop, and adds it to the ACK, and he writes a 5. Next, oh, there's a 5 showing, how nice. Next he sleeps and says, yep, okay, got it, there's a thing. And then he says, add what you found, the message gets sent, and he sends over a 15. So this guy's fine, he just receives messages indefinitely and he's happy. This nicely means we don't even have to synchronize them at all. They can just only send a message when something happens, and it all just sort of works out. So, how exactly are these guys tracking in a previous state? I guess it's just what was in ACK, right? I'm starting to come around to the idea that we might actually be able to write a single chip that does both of these things, but okay, let's not. So what do? Well, first we wire up the chips, and then we say at each step we are going to test equal ACK and P0. And hang on, we can't do that yet. First, we have to test equal P0 to 100. If that was true, it's a little hard to write compound conditionals, isn't it? I mean, you kind of have to do it with a jump, right? So let's say init is this. And if P0 was 100, well, let's say if it wasn't 100, then we will move 0 to ACK, saying that we are now in the state where the button is not pressed, and jump back to init. Oops, that should be a plus, please. Or a minus, I guess. And then a plus is, whoa, why is it highlighting wrong? If we found that it was 100, then, oh, we don't need a plus actually. We can just say test equal ACK to 100. So that means that previously the button was being pushed. So if it was being pushed previously, actually, this one will be simpler if we test for 0. If the button is now pressed and it previously was not pressed, then A, let's move 100 to ACK, and B, let's move 1 to X1. And I think that's all, right? And let's do the same thing here. Oh, there's no -1. Okay. Fine. Can the score ever go negative? Is that allowed? I guess not, because this thing only displays positive.
negative numbers? XBus can handle negative numbers, I forgot. Yeah. XBus can transmit negative numbers, and we're working with XBus the whole way here. So is that a thing I can do? Move -1 to x1? It's not telling me about a syntax error. Alright. Let's see what happens. Step. So they each tested for equality of P0 with 100. They should find that to be false. So they will move 0 to ACK and jump to init. So they'll keep doing this. Oh. I guess we should sleep, huh? So instead of jumping to init, let's not label this. Let's jump to end. And likewise here. And then end, we're going to sleep 1. And that's it, right? Yeah. Okay, try again. What's going on? Oh, I see. Stop. The score needs to start at 0 and there's nothing there otherwise. Okay, so we need to take this line and move it to the top. I can't paste? Alright, whatever. Move ACK to x1. Try again. A 0 got displayed. Great. We have to move that each time? Why? Alright, what's going on here? Oops, I wanted to, yeah, advance time. So we sent that. What? So advance time, we sent that. Now, this is sleeping. But nothing... So now we step, and what happens? These guys just choose to send nothing. And then this... Okay. So apparently this thing wants us to output the correct value to it at every step, not just when it changes. Not sure that I could have known that ahead of time, but okay, that's the way it is. It's not too much trouble to fix. We will just make sure these guys each send a thing every time, even if nothing changed. So, what is the way to do that? I can see a way that involves adding 2 instructions. I don't see a way that involves adding only 1. Right, so the idea is going to be just like, there's sort of 2 places where we might choose to write. We can write here in the like second half of this kind of like nested condition we have here, right? It's only if 2 things are both true do we write. And there's not exactly a shared place for when either of them is false, so we kind of just have to write it in both places. I think. I guess even that's a little bit tricky. No. Here's what we do. Okay, so it still takes 2, but it's not tricky at least. Put it here, please. Minus to move 0 to x1. And here, we'll write the same thing. Minus move 0 to x1. Kind of gross, but I'm not sure what to do better. Move 0, oops. Minus move 0 to x1. And again down here, minus move 0 to x1. And this guy just has the arduous task of writing this whole thing twice, right? He has to sleep, add x0, sleep, add x0, move back x1. Oh, sleep, not sleep, slicks on x0. Okay. So he gets a single value and another value, and he sends. Okay. That's kind of cool looking, isn't it? Those packets traveling over the wire. Kind of crappy the way we have to write it, but it happens to exactly fit in one chip. Remember a while ago when we were so ambitious we thought maybe it was so easy we could fit 2 in a chip? Ugh. Probably we can, I just don't know how. The contracts that you have to fulfill are not very clearly specified, which makes me a bit sad. I've already forgotten how much time we spent. This is about time to end an episode, right? Yeah, 20 minutes. That's fine. Fine to end an episode. Okay, let's read our congratulations first, though. If you can't remember the rules of the game, how sure are you that you made the deal? They sent us a case with a variety of flavors. It's very tasty. It's already too late, but you can still save yourselves. Heed my warning, do not drink of the Baron von Schnapps. See you in the next life. Wow, did this guy kill himself? That's a little sad. Okay. Well, there you go. There you have it. We wrote a drinking game scoring app after much gnashing of teeth and rending of garments. There's a lot going on there that was not well specified, that I wish it better specified so I didn't waste time implementing things that were incorrect. Anyway, that's it for this episode. Thanks for watching, and I'll see you next time.